the quiz answers for applications of Newton's laws and elasticity. Question 1. A 194 Newton force is needed to slide a 50 kilogram box across a flat surface at constant velocity. What is the coefficient of kinetic friction between the box and the floor? The most important fact here is that it's moving at constant velocity, which means that there is no acceleration. And if there is no acceleration, that means there is no net force. Again, if there is no net force, that means the force that's being applied, 194 newtons, is just equal and opposite to friction. So they cancel out, and that's why there is no net force. So that's the applied force. Friction is always opposite, and acceleration is 0. Because the net force is Fa minus F, which is 0 since there is no acceleration. So the applied force is equal to the force, which is force of friction, which is 194 Newton. And then remember that the vertical forces are: one is the weight of the object, mg, acting down, and the other force along the y-axis is the normal force acting vertically up. And since there is no motion along the y-axis, these two have to be equal to each other. And mu is defined as, mu is the coefficient of friction, and it is defined as the friction force divided by the normal force. Since friction is 194 and normal force is equal to the weight m times g, we calculate mu to be 0.40. In the second question, you push downward on a trunk at an angle of 25 degrees below the horizontal with a force of 750 newtons. The trunk is on a flat surface and the coefficient of static friction is 0.70. What is the most massive trunk you'll be able to move? So you got to find the maximum mass that you can move in this way. Now that's the force being applied, which can be resolved into two components. So that's 750 cos 25 and 750 sine 25. And then you have the force of friction acting in the opposite direction. And you also have the weight acting vertically down, as shown here, and the normal force acting vertically up, which I will show now in a second. But remember that when you take the components of 750 Newton, you get 679.9 along the x-axis because it is 750 cosine 25, and then you get the vertical as 750 sine 25, which is 317 Newton. So since we have the x component and the y component now, and frictional force is mu s times Fn because it's static friction in this case. So that's the formula for friction. Now let's take the net force along the y-axis. Okay, so now that is three forces now along the y-axis. One is the weight, the other is Fn, the normal force, and the third one is the y component, which is 317 newtons. So net force is Fn minus mg minus 317 is equal to 0. And then when you rearrange that, you get Fn is 317 plus mg, and then plug it back into this equation. So friction would be mu s times 317 plus mg. Now mu s is given as 0.70. So you have that equation, and now when we take the net force along the x-axis, you have only two forces, 679.97 newtons, and friction. That should be equal to max, but the problem says that we just need to be able to move the object, which means it's not accelerating. So ax is 0 and the right side becomes 0, which again means that these two forces are equal to each other. I've now substituted the value of friction from here, and you just got to solve this equation. So that's when you distribute this, you multiply these two numbers, you get this. And then the second term is this one. Take the difference between these two, you get 457.8. And then calculate the mass to be 67 kilograms. In the third problem, there is a 6 kilogram box sliding down an inclined plane that makes an angle of 39 degrees with the horizontal. The coefficient of kinetic friction is 0.10. At what rate does the box accelerate down the slope? Here again you got to make the free body diagram. Look at the forces. Obviously the weight, the normal reaction, and then you got to get the components of the weight, which is the x and the y here. And since this angle will also be 39 degrees from the geometry of this, you're going to get this y as cosine theta and the x as sine. So that's mg, and then you have mg cosine theta and mg sine theta. This is the normal force. Considering the net force along the y-axis, we only have two, so they should be equal to each other. Plug in the values of the mass, and G is 9.8 cosine 39, which gives 45.7 newtons. Now we can calculate friction, because friction is mu k times Fn, which is 4.57 newtons. And then take the net force along the x-axis. There are two forces, and since the object is moving down, this must be greater, so it's mg sine theta minus f equal to max, and we're trying to find the acceleration. And we already got the friction as 4.56, so do the math and you would get ax as 5.4 meter per second squared. I think this is 4.57, but it doesn't matter. That's just a small difference. So that's how you do that. And number 4, a student pulls a box of books on a smooth horizontal floor. Smooth meaning there is no friction, and the force is applied in a direction 37 degrees above the horizontal. The force is 100 newtons. Mass of the box in the books is 40 kilograms. What is the normal force on the box? Again, sketch the free body diagram and you get this broken up into its two, and then you have the weight acting down and the normal force as before. It's going to be 100 cosine 37, the other is 100 sine 37. And you're asked to find the normal force. So take the forces along the y-axis. Net force along the y-axis. You have Fn and you have 60.2, so add both, minus mg is equal to 0. And mass is 40, g is 9.8. When you work that out, and calculate the normal force, comes out to be 332 newtons. A sports car of mass 1000 kilograms can accelerate from 27 meter per second, from rest to 27 meter per second in 7 seconds. What's the average forward force on the car? So here you have the initial velocity, you have the final velocity is 27, and the time from which we can find the acceleration. So that's the initial, starts from rest, so that's 0. Final is 27 meter per second. Time is given as 7 seconds. And you are trying to calculate acceleration. Use the kinematic equation. Acceleration is change in velocity by time. That gives 3.86 meter per second squared. And then force is mass times acceleration. So that's 1000 times what we have, 3.86. And you get 3,860 newtons, which is, considering significant figures, 3.9 times 10 to the 3 newtons. So that's the problem. And in number 6, there's a traffic accident and police find skid marks 90 meter long. They know that the coefficient of friction is 0.5. You got to find the speed of the car when the brakes were applied. So in this case, the final velocity is 0. We do not know the initial velocity. You know the displacement. And you should be able to find the acceleration. So let's get the formula for coefficient of friction. And from there you know that friction is mu k times mg, because in this case the weight mg is equal to Fn, so it's actually mu k times Fn, but Fn is equal to mg, so I've written that. And Fk is m times a, so m times a is equal to mu k times mg. Mass gets cancelled from both sides and you get the acceleration as 0.5 times 9.8, which is 4.90 meter per second squared. Once you have the acceleration, we can use the kinematics equation to find the initial velocity. I'm taking it as negative because we know that it's a deceleration. And the reason is because friction is an opposing force. The speed decreased, it's a deceleration. That's why I've taken it as negative. So that's the kinematic equation that you have to use. The displacement is 90 meters. So plug that in, rearrange and calculate. Remember that you got to take the square root of this number and you would get 29.7 meter per second. In the seventh one, this is to do with Young's modulus and it's a direct question. We know that the extension is given by this formula. The area of cross section is 1 millimeter squared, which when you change into meter squared is 1 times 10 to the negative 3, because 1,000 millimeters make a meter, but then you got to square it, so it becomes 10 to the negative 6. Now the force applied is 1,000. We have the area of cross section. Young's modulus is 10 to the 11 and the original length is 100 meters. That gives us 1 meter when you do all the calculations. That's how much it stretches. In the eighth one, a similar question. I won't spend much time on that because it's exactly the same. The only difference is that you are given the diameter here and then you got to calculate the area using pi r squared. Because the cross section of the cable is circular and that is the area of a circle. Again, millimeter has been changed into meter here. So once you get the area of cross section, plug it back into the equation. That's the Young's modulus. The original length is 11.2 and that gives 3.5 times 10 to the minus 2 meter, which is 3.5 centimeter. So that is the answer. And in the ninth one, a horizontal force of 5 Newton accelerates a 4 kilogram mass from rest at a rate of 0.5 meter per second squared. What's the friction force? Straightforward, direct question. You see the horizontal force and you see friction. So the net force should be 5 minus friction, which should be equal to mass times acceleration. That's the mass and that is the acceleration. Oh, the product there is 2. I'm going to change that. It's not 20. Yeah, 2. And so when you rearrange, you get 5 minus 2, which is 3 Newton. Can there be anything easier than this? And that brings us to the last question. An object sits on a frictionless surface at 10 Newton force is applied and it accelerates at 2 meter per second squared. What's the mass of the object? Now, that is a joke. So easy. And force is mass times acceleration. There is no friction here, so the only force is 10 Newton. And therefore the mass is 5 kilogram. I hope this has been useful. Thank you and good luck.